And welcome to Technology Tap. I'm Professor JRod. In this episode, we're going to talk about TCP versus UDP. Let's get into it. All right, guys, welcome. For those of you who don't know who I am, my name is Professor JRod, and I do CompTIA podcasts on how to strategies for the exam, questions and topics that are on the various A+, Network Plus, Security Plus exams. I'm now on TikTok. Please, if you are a TikTok fan, go on TikTok, look for me, Professor JRod. I'm there. I post like one question a day that we can go over in the strategies on how to answer that particular question. So if you want, look for me, search for me, Professor JRod. That's JRod. And hit the like button. Follow me on TikTok. Watch the videos. I put a couple of them up already on CompTIA questions. So it should be, let's see if we can get that side of social media active. And also, I want to wish everyone a Happy New Year's. Happy New Year, guys. It's a New Year's 2024. I think it's the time that you guys have decided that, yes, I'm going to take the plunge. I'm going to go and take my CompTIA A+ exams. And hopefully listening to these podcasts would motivate you and help you take the CompTIA A+ exams. And if you do, email me, Professor JRod. That's JRod at gmail.com. Tell me that you passed. Tell me that you took the and passed. And if I helped you, you can tell me that too. I love receiving emails from people telling me that they passed the CompTIA exams. So this topic today, we're going to talk about TCP and UDP. That's Transmission Control Protocol and User Datagram Protocol, which are both on the transport layer of the OSI model. That's layer 4. And they have some key differences in terms of their features and their behaviors, and I kind of want to go over some of them. So first, we're going to talk about connection-oriented and connectionless. The terms connection-oriented and connectionless refers to two different fundamental communication models used in computer networking, particularly in the context of transport layer protocols like TCP and UDP. So TCP is connection-oriented. So connection-oriented communications involves the establishment of a dedicated logical connection between the sender and the receiver before the actual data transfer begins. Right? And the characteristics of these are reliability, which ensures a reliable and ordered delivery of data. Acknowledgements uses acknowledgements to confirm the receipt of the data, and then error handling, which performs error checking and retransmission of lost or corrupted packets. Also does flow control, which implements flow control mechanisms to regulate the flow of data. So, for example, that as you may or may not know, TCP establishes a three-way handshake. And once the three-way handshake is completed, a virtual circuit is established where it provides a reliable byte stream communications. So an example of this would be applications that guaranteed delivery and order data transfers, such as transferring files, when you go web browsing, and particularly email, right, when you need to be very, very reliable with email. And then connectionless, which involves UDP. Connectionless communication does not involve the prior establishment of a dedicated connection before data transmission. There's no three-way handshake. And characteristics: no connection setup, data sent without prior setup or acknowledgement, no reliable guarantees, does not guarantee the delivery or ordering of packets, and low overhead, generally has lower overhead due to the lack of connection setup and the acknowledgement process. And if you look at some literature on TCP UDP, you'll see that the amount of data that is in each one is vastly different. So an example of this is, again, like I said, UDP sends data without establishing a connection, does not provide reliability features like acknowledgement or transmission. And an example of this is real-time application, where low latency is critical, such as streaming media, online gaming, and VoIP, right? They're just going to send you the data. They don't care if you are ready for it or not. They're just going to keep sending you the data. Situations where some data loss is acceptable and the emphasis is on speed rather than reliability, that sounds like Netflix, right? Or YouTube. They just send you the data, right? Sometimes you may be watching a YouTube video and it kind of skips. That's UDP doing that. So let's compare both, the pros and cons. Connection oriented, the pro is reliable and ordered data transfer, error checking and correction, and then flow control for congestion management. The cons is higher overhead due to connection setup and acknowledgement. Connectionless, the pro is lower overhead, faster transmission, suitable for real-time applications. And the con is no reliability guarantees and no error checking or correction. The choice between the connection-oriented and connectionless communications depend on the specific requirement of the application. Connection-oriented protocols like TCP are suitable for applications that prioritize reliability, when connectionless protocols like UDP are appropriate for scenarios with low latency and speed are more critical than guaranteed delivery. Next, we're going to talk about reliability. As far as TCP is concerned, reliability in TCP, connection-oriented. TCP is connection-oriented protocol. Reliable delivery ensures reliable and ordered delivery of data. Acknowledgement uses acknowledgement to confirm successful receipt of data. Retransmission, if the segment is lost or is corrupt, TCP will retransmit it. Sequence numbers, employ sequence numbers to order to receive data at the destination. Does error checking. TCP includes error checking mechanism, and if errors are detected, the receiver requests retransmission. Flow control implements flow control to prevent overwhelming the receiver with too much data. So an example of this would be file transfer, web browsing, again, email applications where accurate and ordered data delivery is crucial. So you ever downloading something and it says 8 hours, to download, then it says 4 hours, then it says 20 minutes. That's part of TCP. That's TCP doing that. Reliability in UDP, connectionless. UDP is a connectionless protocol. It's no reliability guarantees, right? Doesn't guarantee reliable delivery, and there's no acknowledgement of data being received. Error handling, UDP does not perform error checking or retransmission. Any error detection and correction must be handled by the application layer, and it has low overhead because of its connectionless and the lack of reliability. UDP generally has lower overhead compared to TCP. Again, an example is streaming media, online gaming, when some data loss is acceptable and low latency is more critical than guaranteed delivery. To summarize this section, TCP provides reliable and ordered delivery of data, suitable for applications where data integrity and order are critical. And then the higher overhead due to connection setup, acknowledgement, and error checking. UDP does not guarantee reliability or ordering of data, suitable for real-time applications where low latency is more critical than reliability, and lower overhead due to its connectionless data loss. Connectionless nature. Next, we're going on to the TCP UDP header size. So TCP header is more extensive compared to UDP, containing several fields necessary for reliable and ordered data. The size of a TCP header, the minimum TCP header size is 20 bytes. Additional options such as maximum segment size, window scale, timestamps can increase the size of the header. The maximum size of a TCP header, including options, is 60 bytes. Fields, it has source and destination port numbers, sequence and acknowledgement numbers, header length, flags, window size for flow control, checksum for error detection, urgent pointer, and other options like how variable length. UDP header size is simpler and more compact than the TCP header, containing the essential information for connectionless communication. Size, you can see, I'm going to tell you, you can see there's a big difference. The UDP header is a fixed size of 8 bytes. Fields, source and destination port numbers, length field indicating the length of the UDP header, and data checksum for error detection, which is optional, and it can be set to 0 for no checksum. So again, to compare both, TCP larger header size, especially when additional options are included. More feature-rich header to support reliability and connection-oriented communication. UDP, smaller fixed header, minimal information, suitable for connection and low overhead communications. Next, we're going to talk about flow control in TCP UDP. Flow control is a mechanism used to manage the rate of data transmission between a sender and a receiver. It ensures that the sender does not overwhelm the receiver with data, preventing potential packet loss and ensuring smooth communications. So for TCP, in TCP, flow control is implemented using a sliding window mechanism. The receiver advertises available buffer size to the sender using the window size field in the TCP header. The sender then adjusts its transmission rate based on the advertised window size to avoid overloading the receiver. What's the purpose of this? It prevents the sender from transmitting data at a faster rate than the receiver can process. Congestion control. Congestion control is a mechanism used to prevent network congestion, which occurs when the demand for network resources exceeds the available capacity. It aims to avoid packet loss and ensure fair sharing of network resources among competing users. So TCP congestion control, TCP uses various algorithms to detect and respond to congestion, such as slow start, congestion avoidance, and fast retransmit, fast recovery algorithms. These algorithms adjust the sending rate dynamically based on network conditions, reducing congestion and preventing network collapse. And the purpose of all this is to avoid network congestion by adjusting the transmission rate based on perceived network connections, right? This is why you see it. When you first start downloading something, it's at a different speed when you end it. Comparison. Primary scope is concerns the communication between the specific sender and receiver. Implementation involves adjusting the rate of data transmission based on the receiver's buffer space. And the goal is to ensure effective and reliable communication between individual senders and receivers. Congestion control is the scope, concerns the entire network and multiple communicating entities. Implementation involves the adjusting the transmission rate based on network conditions to prevent congestions. And the goal is to maintain overall network stability with fairness, preventing congestions related issues. TCP incorporates both flow control and congestion control mechanism. Flow control is essential for managing the rate between individual sender receiver pairs. Congestion controls help prevent network-wide congestions and ensure fair utilization. Flow control use case for file transfers. When large files are transferred between the sender and the receiver, flow control ensures that the sender does not overwhelm the receiver's buffer, preventing potential loss. When you are web browsing and web communication, flow control helps manage the rate of data transfer between a web server and a client, ensuring loading of web pages without overloading the client. Email communications, flow control is important in email communications to prevent the sender from transmitting emails faster than the email client can process and display them. And then streaming media and streaming applications such as video streaming or online music service, flow control helps regulate the delivery of data to ensure a seamless and uninterrupted user experience. Congestion control, some examples of that. Internet traffic management. In the broader contents of the internet, congestion control mechanism prevent network congestions by adjusting the transmission rate of multiple connections, ensuring fair share of available bandwidth. Data center communications. Within data centers, when numerous servers and devices communicate, congestion control is vital to prevent bottlenecks and ensure efficient data transfer. VoIP, Voice over Internet Protocol. In real-time communication applications like VoIP, congestion control helps maintain low latency and prevents voice quality degradation by avoiding a network congestion. Online gaming applications use congestion control to ensure a smooth gaming experience by preventing lags and delays caused by network congestion. And cloud computing. In a cloud computing environment where multiple users and applications share resources, congestion control prevents performance issues and ensure fair resource allocation. In scenarios where reliability and ordered data delivery are essential, for example, file transfer, web browsing, and email, TCP flow control ensures that data is transmitted at a manageable rate. TCP's congestion control helps maintain network stability and fairness in diverse and dynamic network environments. Next, we have the well-known ports that are used in TCP UDP. As we know, ports are standardized port numbers assigned to specific service. By the Internet Assigned Numbers Authority, these ports are commonly used for well-known services, making them easier for network administrators and users to identify and manage different network traffic. Here are some examples of some well-known corresponding ports and the services. Well, first one we're going to mention is port 20 and 21, which you should know it before I say it, right? Ports 20 and 21 is what? FTP, File Transfer Protocol. And now, is that UDP or TCP, guys? What do you think? It is TCP. Next, port 22. And port 22 is what? What is it? That is correct. It is Secure Shell. And now, is that TCP or UDP? What do you think, guys? It is TCP. Next, we have port number 23. What's port number 23, guys? All of these are, the ones are going to be in A+, Network Plus, and Security Plus, so know them. Port number 23 is Telnet, and that is TCP. Next is port number 25. Anybody can tell me what port 25 is? Those in the back, what do you think? It is SMTP, and it is TCP. Next is port number 53. And what is 53? Port number 53, what is that? That is domain name service. And now what protocols they use? This one actually uses both. TCP and UDP. And then one day we'll talk about DNS, and then we'll get it into a little bit of a deep diver on that. Next, we have port 80. Everybody should know this one, right? This is the easiest one. This should be like the first one that you learned. And it is HTTP, right? Hypertext Transfer Protocol. Now, is that UDP or TCP? What do you think? It is TCP. Port number 110. Port number 110. What do you think that is, guys? What do you think that is? Before I give you the answer, take a guess. Port number 110 is POP3, Post Office Protocol. And that protocol uses TCP. Next, port number 143. 143, guys. What's 143? 143 is HTTPS, right? HTTP secure. And that uses TCP. Port number 161 and 162. What protocol is that? Anybody know? This one is a little harder. It is SNMP, Simple Network Management Protocol, and that uses UDP. Next is port number 389. 389, guys. What port number is 389? Anybody know? Goes in the back, yell it out. Port number 389 is LDAP, Lightweight Directory Access Protocol, and that uses TCP. Then we have port 514. Port 514. This is the tough one. Port 514. Anybody know what that one is? Port 514. That is syslog. Right? Protocols are UDP and TCP. Next, we have port number 636. Anybody know what that is? 636. No, it's LDAP-S, LDAP over SSL. And then again, that also uses TCP. And the last one is port number 993. 993, guys. You guys know what that is? 993. 993 is IMAP over SSL, and that also uses TCP. These well-known ports facilitate the standardization of network services, allowing devices and applications to communicate with each other using established port assignments. While these ports are associated with specific services, it is important to note that applications can sometimes use non-standard ports or dynamically assigned ports for communication. All right, we got some more ports. Port 67. This one you should definitely know. Port, especially if you took my class, right? Port number 67. What is that? It is DHCP, Dynamic Host Configuration Protocol. And is that TCP or UDP? Yeah, that's UDP. You would think it's TCP, no, but it's UDP. So I'm sure some of you are shocked. Port number 69. Port number 69. Anybody out there know what port number 69 is? No? Port number 69 is Trivia File Transfer Protocol. It uses UDP also. Next, this is the easiest port number that you can remember in your life. If you ever get this wrong on the test, shame on you, because this is the easiest port number to remember. Port 123. What's the name? What's the service? What's the name of port number 123? That's an easy one. That's like a gimme, guys. If you don't know that one, you need to go back to your notes. That's Network Time Protocol. Network Time Protocol. And it's easy to remember, right? Because it's time, 1, 2, 3, time, right? Very easy to remember. Then we have the last one is port number 514, which is syslog, and that's both UDP and TCP, along with SNMP. That's also both. So please note, while these ports are commonly associated with specific services using UDP, some applications may use non-standard ports or dynamically assigned ports for UDP communication. Additionally, some services such as DNS uses both, with UDP typically being used for lightweight queries and responses. So, all right. So hopefully that was a good topic, right? UDP, TCP. Not a lot of people know that, and it's a very, very, very important part of IT, and it's part of the OSI model. It's layer 4 of the OSI model. It has to do with the transport layer, and it has in its packet the port number that it's assigned to it. So it's a very important topic that we need to understand in IT and computers and CompTIA and A+. Now I doubt very much you're going to talk about that at work, about TCP and UDP, but you may need as you go along in your career, right? Because there's TCP flooding, right, that they do. So you may need to know about TCP, right? This is It's not the most glamorous topic, and you might say, "Wow, this is a little bit on the boring side," and it is. But they will attack, right? They would do that attack where the three-way handshake doesn't get completed. Only the two-way. It only stops at the second handshake, and then it just keeps doing it, and then the third handshake never completes, and then your system is done after a while once they do it a bunch of times. So it's an important aspect of IT, though it may not be, anybody's favorite thing, or it might be a little bit boring, or even after listening to this podcast, you may still not understand what it does, what it means. But this is just just to tip your toe in the water kind of thing, and see if you can at least start to familiarize yourself with TCP UDP, because it's very important. The example that I like to give in class, if anybody ever taken any of my classes, is I like to have one student stand at one end of the classroom and I'm on the other end, and I have a bunch of markers in my hand, and then I start tossing them to the student on the other side. But I say, "Hey, are you ready?" And then they say yes, and then I toss them the first one, and they say, "Hey, are you ready?" And they say yes, and I toss them the second one, and they say, "Hey, are you ready?" And they say yes, and I toss them, and I continue tossing them. Then I grab the markers back. We're still in the same position. And then I start tossing the markers at the person. If he drops it, I don't care. I'm not waiting for him to pick it up to throw the other marker. I'm just going to I do it underhand, of course, right? Not to get hurt. And then I just keep throwing the markers. And after a while, he stops catching them, right? That's how TCP and UDP works. That's the example that I like to show my students, like a visual example. May not be the best example, but it's a fun example, and it gets a lot of laughs in the classroom. So I'll take it. If it's gonna make my students laugh, I'm all there for it. All right, that's gonna put a bow on this episode. Thank you for listening, and remember to follow me on TikTok. I'm on TikTok. Just search for Professor JRod. JRod, and you would find me. Take a look at some of the videos that I put up there. Hit the like button, please, and follow me. I'm trying to get enough followers for I can do a live stream, and we can do a whole bunch of questions live. I appreciate it, and until next time. This has been a Little Cha-Cha Productions. Art by Sarah, music by Joe Kim. If you want to reach me, you can email me, Professor JRod, that's JRod @gmail.com. I'm also on Instagram at Professor JRod, and I'm on TikTok. Search for me, Professor JRod.